session that we will be talking about logistic regression. Now, have you heard this term before? Have you have any idea regarding logistic regression? I will try to start from scratch, but before starting, I will request you that if you can share your experience about logistic regression. Have you heard it, or you will be doing for the first time along with me? Please unmute yourself and talk with me, no issue.
Sir, basically, I am not a student of commerce or I haven't learned statistics. I just learned a few statistical analysis just for which are uh, useful in research. So I haven't heard anything about this binary logistics and all these things.
Ma'am, you are from which stream?
Basically, I did my PhD in microbiology, but
Okay.
from last 33 years I am teaching science subjects in home science, and
Okay.
I'm guiding students in home science only. That's why I wanted to learn SPSS. But I have just learned a few problems regarding biostatistics, few things which are useful in research only.
Actually, there are a lot of applications in home science and biostatistics for SPSS. If you learn SPSS, you can do wonderful analysis in your stream.
Yeah, from last, I think from last 3 to 4 years, continuously I was registering myself for SPSS in this Ekedas Gupta Training Center only. But
Okay.
uh, due to one or another reason, I couldn't able to go there for offline training. And this time it's my luck that I got it online, so I could do it because I am principal in a college, and my under there is arts, commerce, and home science. Three faculties are there.
Okay.
So usually I don't able to go for training, offline training for 10-15 days. So
Uh,
for me, this is very much useful.
where you are staying in Gujarat or where?
In Gujarat, Surendranagar district,
Okay.
it is in between Ahmedabad and Rajkot.
Okay. 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 Thank you.
Okay, thank you.
So, any other participants want to share your experience? Have you heard about this logistic regression?
Yes, sir. So, logistic regression is a type of linear regression, and regression deals with the degree of the relationship between two variables. And logistic regression basically in three types, that is binary and ordinal and multi-nominal logistic regression.
So, have you used this technique for your analysis in your work?
So, till now, I have not used it.
Any other participant? Are you all with me? You can hear me, I think.
Yes, sir.
Okay, then I shall start. Uh, as I always customary start my session with a prayer. So let me start with a prayer and then we will go on to discuss. Om, lead us from unreality to reality. Lead us from darkness unto light. Lead us from death to immortality. Om, peace, peace, peace. So I will be sharing my screen. I have already sent you the data sets as well as the PPT. I will be using the PPT. I will write some notes in the Word file as well, as I did yesterday. and I have shared you two data sets. I think you have got it. One data set talks about the real estate problem. The other data set talks about actually that data set talks about the counseling center where mental problem patients have gone there and they seek counseling, and those who are well enough, they are terminated first, and those who need diagnosis and treatment, they are staying there in the counseling center. So that is the data set about. I will be today demonstrating the real estate data set, and the terminate data set will be for your practice. At the end of the session, I will discuss in detail about the data set, the story of the data set that you are going to practice. So just tell me that whether you have got the data sets and the PPT as well.
Yes, sir.
So
Yes, sir.
as yesterday, will you be able to do hands-on with me? Are you ready?
Yes, sir.
Yes, sir.
Okay. Then I will start with the concepts as I did yesterday. I will start with the concepts. Then I will use a little bit of PPT, and then I will start the demonstration session. So please be ready with the PPT as well as the data sets. When I ask you, when I start demonstration, you should also do along with me. I will go as slow as possible, and recording is also taking place. So so you can practice several number of times by listening to the recorded version as well. So just to keep my internet connection stable, I am switching off my camera and I will be sharing the screen. At any point of time, if you cannot see the screen, please tell me that something is going wrong. Otherwise, I will not be able to understand. So please, at any point of time, if you need to talk with me, you unmute yourself and talk with me. Don't put anything in the message box, because when I will be demonstrating, I will not be able to see the message box. So let us start. Are you able to see my screen?
Yes.
Yes, sir.
Okay. So today we will start with our discussion on logistic regression. Now, before going to the concepts of logistic regression via PPT, let us start something with a writing format. I think my screen is visible.
Yes, sir.
Yes.
So today's topic is about logistic regression. Now, generally, when we listen to logistic regression, one thing comes to our mind is that why not multiple regression? Why not simple regression? Why there is a need to discuss about logistic regression, and why we will be doing logistic regression? So can anyone tell me that why applying multiple regression is not enough? Why we need to do logistic regression? what is the difference between multiple regression and logistic regression? Can anybody tell me? Any volunteer? I think you can hear me. I'm audible and my screen is visible.
Yes, sir.
Yes, sir.
So, any idea? Please interact, otherwise it will be boring. Because we are doing a online class. I don't know whether you are listening properly or not, whether you are serious and interested or not. So just to give me signal when I'm asking some questions, please try to answer. You may be wrong, no issue. Don't be shameful, because we are all learning. So anybody can tell something?
No idea, sir.
Have you any idea about multiple regression or simple regression? Have this has been done in our course till date?
No, sir.
Okay.
Not
So
knowing.
generally what happens is, in case of single or for that matter simple regression, here you know that there is dependent variable and there is independent variable. Now when there is a single independent variable, we call it single or simple regression, and when there are more than one independent variable, we call it multiple regression. Now generally what happens is, say if we write like this, say y is equal to, say, a plus bx. So here x is the independent variable, y is the dependent variable. So we call it as a simple linear regression. Now suppose you have more than one independent variable. Say I write like this, a0 plus b1x1 plus b2x2 plus, say, epsilon or error term. Then here we have two independent variables. So we call it as a multiple regression. Now, the assumption in case of multiple linear regression or simple linear regression is that there is a linear relationship between the dependent and the independent variables. There is linear relationship. And for that, we have to test some assumptions, that whether our independent variables are following normal distribution or not, whether the epsilon or error terms follows normal distribution or not. These things we need to check before running multiple or simple linear regression. So this is a linear concept. It is a linear concept where both the dependent variable and the independent variable are continuous in nature. It is continuous in nature. I have already talked about yesterday that generally there are four types of variables, or if you measure the variable in scale, then there are four types of scale. One is the nominal, second is the ordinal, third is the interval, fourth is ratio. So when you are measuring a variable which is in interval or ratio scale, we call it as a continuous variable. And when we are measuring a variable which is in nominal or ordinal scale, we call it as a categorical variable. So in case of multiple linear regression and simple linear regression, the assumption is that the variables are continuous in nature. Both the dependent variable and the independent variable are continuous in nature, and it follows a linear relationship. Only then we can apply simple linear regression in case of one independent variable. In case of more than one independent variable, we apply multiple linear regression. Now, maybe that in real life, your variables may not be continuous in nature. It may be categorical in nature. Now, here comes the application of logistic regression. If the dependent variable, say, is categorical in nature, I think my screen is visible. You can see it.
Yes.
Yes,
Yes,
sir.
sir.
So, in case of logistic regression, these independent variables may be continuous, may be categorical. Some may be continuous, some may be categorical, but the dependent variable should be categorical in nature. If it is categorical in nature, then we apply logistic regression. Why? Because we cannot apply simple linear regression or multiple linear regression. Then why? Because the dependent variable is no more continuous in nature, it is categorical in nature. Now, the fact is that in case of simple linear regression or multiple linear regression, the assumptions is that the variable should be normally distributed. But in case of logistic regression, when there is involvement of categorical variables, basically in case of dependent variable, if it is categorical in nature, then it cannot follow normal distribution. So that's why we have to convert it into log form. That's why it is called logistic regression. We are converting it into log form. So we may call it as a distribution free concept. Now, this dependent variable may be binary, means two choices between, say, yes or no. Yes, we may code as 1, no as 0. Then there may be ordered, and there may be multinomial. What does this mean? This means that if your dependent variable has two categories, we call it as a binary logistic regression. If it has more than two categories, we call it as either ordinal or multinomial logistic regression. Say, between yes and no, if, say, we introduce neutral, then it becomes a three category case. When there is three category case, we cannot apply binary logistic regression anymore. We have to apply ordinal or multinomial logistic regression. Now, what is the difference between ordinal and multinomial logistic regression? The difference is that if your dependent variable categories are ordered, if it is ordered, say we are following a Likert scale, 5-point Likert scale. So we call it as, say, 0, 1, 2, 3, 4. 0 is, say, strongly disagree. 1, agree. 2, say, neutral. 3, say, agree. This is strongly suppose 0 is strongly disagree, 1 is disagree, 2 is neutral, 3 is agree, and 4 is strongly agree. Like this, it is ordered. So in case of dependent variable which are ordered in nature, we should apply ordinal logistic regression. And if the dependent variable is more than two categories and if it is not ordered, then we should apply multinomial logistic regression. So this is the basic concept of logistic regression. Now, I will try to touch upon little bit of algorithm or mathematics behind this logistic regression to make you understand better. And then we will go on to discuss, we will do the hands-on session. Now, can you tell me that this is clear to you till now what I have discussed?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Hello.
Yes.
Sir, in logistic regression, the dependent variable may be categorical or continuous, but the independent variable should be categorical in nature, right?
No, no, just the opposite.
Opposite, opposite. Okay, okay, okay.
Dependent variable should always be categorically. The independent variables
Okay, sir. Okay, sir.
may be continuous, but the dependent variable should always be categorical in nature.
Okay, sir. Thank you.
Now, when the dependent variable, say in your model, the dependent variable is binary variable, we call it as a binary choice model. Now, in such a model, the dependent variable actually involves only two choices, say presence or absence of any, say, attribute or quality, etc. Like we call it as yes or no. Now, generally what happens is, say, we can take an example. Say, suppose we are interested to know the determinants of, say, choice of occupation by the rural workers. So the rural workers usually have two choices, either to work in a farm sector or, say, non-farm sector. So we may be interested in knowing that what determines the rural workers' choice between, say, farm sector or non-farm sector, or farm occupation or non-farm occupation. So here we are considering a binary choice model which considers workers' occupational choice as a dependent variable. And the independent variables may be, say, workers' age, maybe, say, sex, maybe, say, education, maybe, say, parental education. All these are independent variables or explanatory variables. But the dependent variable is the occupational choice. It is a qualitative variable which should be quantified by using the dummy or binary variable in the form of 0 and 1. So we may say that 1 is, say, non-farm occupation and 0 is farm occupation. So this is how we have to identify that whether their dependent variable is binary or not, and whether we can apply a binary logistic regression or not. Now, in case of binary logistic regression, the example which I have already shared with you, just now discussed. So here, the concept of dummy variable comes into picture. Why? Because your dependent variable is coded as dummy 0 or 1. Now, when the dependent variable is dummy or binary choice model, then three type of approaches is possible. Three approaches is possible. What are the three approaches? One is linear probability model. The second one is the logic model or we may say logistic regression model. And the third one is probit model. So today we will be focusing our discussion on this logic model. Now, you may say that what is the difference between, say, linear probability model or logic model or probit model? Generally, logic and probit model is more or less same. They both have a sigmoid curve, S-shaped curve, but the distribution function of logic and probit is different. But in case of linear probability model, you can very well identify that it is a linear probability. So linear case is there. But as our dependent variable is categorical, so it is non-linear. So in that sense, we cannot apply linear probability model. Now, I can start with a linear probability model and show you what is actually the limitations behind this linear probability model, and then the usage of logistic regression or the logic model comes into the picture. So it will be a little mathematical. Now, I will try to make it as simple as possible in order to make you understand. Whether you can understand what I am telling? Okay.
Yes, sir. Yes, sir. Yes.
Okay. So let us start with a linear probability model. Let us check one of, there are lots of limitations. I will just check one limitation and will tell you that then there is scope of applying logistic regression there. So let us start with the linear probability model. So suppose, say, we want to determine the car ownership status of, say, families in our locality. So we hypothesize that the car ownership status of the families is determined by their family incomes. So to examine the validity of the hypothesis, suppose we collect sample data, and in our samples, some families will have car and some families don't have car. So the basic points that we will note here is that car ownership status is a qualitative variable, and car ownership status should be quantified by using a dummy or binary variable, say 1 if the family owns a car and 0, say, if the family does not own a car. And family income will be a qualitative variable, you know. So we may write the model like this. We may write the equation like this, say yi is equal to alpha plus beta xi plus epsilon. So here yi is the car ownership status and xi is the family income. So we may write xi is equal to family income and yi, actually yi will have two values, say 1 if the family, say, owns a car, and 0 otherwise if the family does not own a car. So this example is clear, and epsilon is the, say, error term or disturbance term or error term. So this is clear? The example is clear to you?
Yes, sir.
Now, suppose this is the first equation. Now, we may write like this, say, suppose yi is taking value either 1 or 0. So the we may write like this. We may describe the, say, the probability distribution of yi by, say, writing like this, say pi probability distribution of, say, yi is equal to 1, because yi will be either 1 or 0. And then we can write like this, and therefore 1 minus pi should be the probability of yi is equal to 0. We may write like this. Till now it is okay?
Yes, sir.
Yes, sir.
So then we may write like this, say expectation of yi is equal to 1 into pi plus 2. Either it will be 1 or it will be 0. So 0 when 1 minus pi is equal to pi. We may write second equation. Now again from the first equation, we may write now, again from this first equation, we may write like this. E yi by xi is equal to alpha plus beta xi. So this will be the third equation. Now if we compare equation 2 and 3, if we compare equation 2 and say 3, then what we can write? We can write like this. E is equal to expectation of yi by xi is equal to alpha plus beta xi is equal to pi. So this may be equation 4. And probability will range from 0 to 1. You know that. So we may write like this. Will be ranging between 0 to 1. Clear?
Yes, sir.
So this is actually called the linear probability model. Now, the fact is that in case of linear probability model, it looks like similar to linear regression model, because we are using the ordinary least square method here. But the problem with the OLS method is that certain assumptions may be violated. How? I'm just sharing with you how the assumptions may be violated in case of linear probability model. So here, in case of, so from say equation 1, just we have erased it. We may write like this: epsilon 1 is equal to, or epsilon say I is equal to yi minus alpha minus beta xi. Now, since we know that yi should be either 1 or 0, so for say any given x, we may just put the value of epsilon like this, say epsilon I is equal to 1 minus alpha minus beta xi when yi is equal to 1. Again, we may write like this: epsilon is equal to I minus alpha minus beta xi when yi is equal to 0. So it is clear from these two equations that epsilon I is not following normal distribution. Why? Because it is a discrete distribution. It is not a continuous distribution. So if it is not a continuous distribution, it cannot be normally distributed. So here the assumption is violated because I have already spoken with you that you can only apply multiple linear regression when your independent variables and the error term is normally distributed. But here you can find that the error term is not normally distributed. So if the error term is not normally distributed, then what to do? We cannot apply multiple linear regression or for that matter linear probability model. Then we have to go for logistic regression. So this is the proof that we need to understand before applying logistic regression, that why there is a need for logistic regression. When our dependent variables become categorical, then the OLS method is not fruitful. Then we have to apply the maximum likelihood estimate method, that is the MLE. So linear regression, multiple or linear regression follows OLS method, and logistic regression follows MLE, that is maximum likelihood estimation method. So this is actually the logic behind this. So this is clear to you? So what is the problem?
Yes, sir.
So now I will come to the odds and log odds ratio just to prove it, that why we are converting it into the log format in case of logistic regression. So let me specify the logic model here. Say suppose pi is equal to p yi is equal to 1. Suppose is a function of say zi, and it may be termed as 1 by 1 plus e to the power minus zi. Now how we are writing this logic model? This is the logic model. Now here P is the probability that yi is equal to 1. Fzi, what does it mean? Fzi is the cumulative distribution function of the CDF of cumulative distribution function of the logistic function. What is Zi? Zi, as you know, I have already written alpha plus beta xi. So this is the predictor variable, and here E, what is E stands for? Is the base of natural logarithm. You know that. What is the value of E? Can anyone tell what is the value of E? We know 2.71828. So this is the value. 2.71828 is the value of E. So basically, just to make it simple, in order to make you understand how we can convert, say how we can convert a say multiple regression to a logistic regression. How the function will change? I am just writing multiple in order to make you understand. Multiple linear regression. This is I am writing the equation, and then I will write the equation of say logistic regression. Then it will be easier for you to understand. how we convert a MLR to a LR. So let us, this we know, this is very easy. Yi is equal to V0, say V1 x1 plus say V2 x2 dot 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 Vn xn plus say epsilon I. This is the multiple linear regression that everybody knows. Now, how we can convert it into a logistic regression? Say probability of yi is equal to 1 by, how we can write here? One by 1 plus, this is, we are writing this one, 1 by 1 plus e to the power minus this one, e0 plus v1 x1 plus v2 x2 dot 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 bn xn. So now this one can be written like, are you getting it? You can,
Yes, sir.
because running the SPSS is very easy. It will give within a fraction of a second all the results. But if you don't know the concept, then it will be difficult for you to interpret and to understand when you will be actually applying this logistic regression. That's why I'm taking so much time today in discussing these equations and concepts, which I have not done yesterday. So this is very vital to understand. So here, this one again, we can write like this, say, Py is equal to 1 by 1 plus 1 by e to the power b0 plus v1 x1 plus v2 x2 plus, just I am simplifying it. Then again we can write if we take this in the numerator, we may write like this: E is equal to b0 plus v1 x1 plus v2 x2 plus dot 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 bn xn by e to the power b0 plus v1 x1 plus v2 x2 plus dot 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 bn xn. So now we may write like this: e to the power logit is the logit function by here 1 plus e to the power logit. So this is the final equation. Actually, the odds ratio, we call it as E logit. So here you may write like this: odds by 1 plus odds. So this is the ultimate equation. So that's why the odds ratio comes into picture. This is clear?
Yes, sir.
So now my job is over. I have come to the equation. Now we will go to the PPT and make you understand. Can you see my screen now?
Yes, sir.
Yes, sir.
So all these things we have discussed. So I'm just going here this logistic regression model. I have written this equation. I have proved it that why it is actually odds ratio. Now come to the logistic regression graph. If you think of a multiple linear regression, it is a linear regression curve. But here it will follow a straight line. But here you can see it is a S-shaped curve. That's why we call it as a sigmoid curve. So basically, now again, if I go to the Word file and write it, the graph, if I draw, then it will look like this. Generally, in case of, say, multiple linear regression, the graph look like this. So it is a case of multiple linear regression. But in case of logistic regression, it is somewhat S-shaped. So why? Because the probability value in case of linear regression, sometimes it may be negative, it may be positive, but here it will be lying between 0 to 1. That's why it is a S-shaped curve. That's why you can see this is as a S-shaped curve. So here odds ratio has been defined. I have already shown you the odds ratio, odds by 1 plus odds, that is the log odds. I have shown you. So let me come to the binary logistic regression now. We will start with the binary logistic regression. So before doing the binary logistic regression, we need to check the assumptions that your assumptions in case of your dependent variable, it should be measured in a dichotomous scale. It should be binary in nature. Either yes, no, or say male, female, it should be nominal in nature rather. So there should be two choices, say introvert, extrovert, obese, not obese, like this. And your independent variables may be either continuous, it may be measured in interval or ratio scale, or it may be in categorical scale. So both categorical as well as continuous variables are permissible in case of independent variables when you are running logistic regression. The third assumption is that the observations that you draw should be independent in nature. It should not be repetitive. And basically what we are doing, we are converting the nonlinear form into a logit form, because when your dependent variable becomes categorical, so no more there is a linear relationship. So we are converting into a logit transform with the log. So we are taking log on both sides, and therefore when we are using log, automatically again the logit transformation on the left hand side, that is on the dependent variable side, and the continuous variables or categorical variables in the independent side, it becomes linearly related. So basically what happens is, since we are using a logic transformation and we are classifying, actually this logistic regression is a classification concept like cluster analysis. So today I will try to touch upon that. Since we are again converting, we are trying to find a linear relationship between the logic transformation and the independent variables. So there may be some misclassifiers. But if you go for an advanced study where you actually do a nonlinear regression, that is taking both side nonlinear, then nowadays in the machine language concept, support vector machines has come. So we use support vector machines in order to reduce the misclassification. Here in the limitation of logistic regression is that there may be certain misclassification I will discuss, but if we use support vector machine, since it is a nonlinear regression, so the misclassification reduces a lot. So that will be a very advanced study. So just try to understand the logistic regression. The limitations are there in every analysis, and that's why research is going on to make advanced analysis to reduce the misclassifications and the limitations. So don't try to focus on those things. Let us try to focus on the binary logistic regression now. So here I am showing you a case study where this is a real estate case study where Sally is a woman who is a successful real estate sales lady, and she was interested in developing a way to predict that whether the potential home buyers who are coming to meet Sally in their first meeting, that whether they will ultimately buy the flat or not, buy the flat or home or not. And supposedly her father was a statistics professor. He was a retired statistics professor. So Sally went to her father and requested him to actually develop a regression equation in order to predict that whether the potential home buyers will be buying homes or flats from Sally or not. So Sally and her father discussed some of the key variables by casual observation of the potential home buyers and taking information from them. So on information on these key variables were routinely obtained from the first initial meeting with Sally, and 30 such potential home buyers interaction was sought, and 30 data were collected on 4 variables. So what are the 4 variables here? The 4 variables is have the potential buyers been pre-approved for a loan when they are coming to meet Sally, whether they have taken a pre-approved loan from the bank. If it is yes, then it is coded as 1. If it is 0, then it is coded as no. So no is coded as 0 and yes is coded as 1. Next is that when they are coming to meet Sally, they are showing interest by asking certain questions regarding the home or flat or not. So if they are asking questions, if they are showing interest, positive interest in the flat or home, then yes is coded as 1 and no is coded as 0. The third is how much down payment they can make to book the flat or home. It is measured in thousands of rupees. So it is a continuous variable, you can understand. And the other variables are categorical. And did they ultimately purchase a home from Sally? If yes, then 1. If no, then 0. So you may say that purchase or sale, it is a dependent variable, and the independent variables are how much they are making for down payment, whether they are asking questions or not, whether they are showing interest in the first meeting or not, and whether they have a pre-approved loan or not. So this is the equation that Sally's father have developed. The dependent variable is sale or no sale, and the independent variables are whether they have pre-approved loan, whether they have shown interest in buying, and whether they have money for down payment or not. So this is the case study. So this is clear to you?
Yes, sir.
So what are the research questions? The 2 research questions here are: could we predict whether a client would purchase a home if we knew whether he or she has a pre-approved loan, whether she or he has shown interest, and whether he or she have down payment, the amount of money to go for down payment? And if we could predict the outcome accurately, that whether they will buy or not, what are the variables which are influencing them? So these are the 2 questions. So we need to evaluate. Now, when we are classifying between a buyer or a non-buyer, so it is a classification technique. So multiple choices are available. Now, depending on your model, you have to find the best model. So generally, you have to try to minimize the classification error. You should try to maximize the accuracy and minimize the misclassification. So we call it as a error rate. Generally, the amount of misclassification, the more the error rate will be more. So this is actually a confusion matrix where we will be actually comparing between the actual and the prediction. So I am not going into details now. I will show you all these confusion matrix and all these classifications with the help of a real data set. So I will come into this true, positive, true, negative, this confusion matrix later. So let us now go to the data set first. So I think you have the real estate data set. This is the binary logistic real estate example data set. Please click it. Are you with me? You can follow me, I think. I'm audible.
Yes,
Yes, sir. Yes,
yes,
sir.
sir.
Yes.
And my screen is visible.
Yes.
So please open this data set. I have already sent to you. When you are ready with your data set, please tell me, then I will proceed.
Ready, sir.
So all of you are ready? If you are ready, then please in the message box, type ready. Only one message I have got till now. Only 3. 4, 5 out of approximate 20. I have got only 5. Other 15 are not ready or sleeping. I need at least 10 answers. Then I will proceed. I've got 7, 8. Till now, I've got 8. So what should be our assumptions? That 8 are in the class going along with me and others are physically present but emotionally absent. So others, please unmute and talk with me whether you are ready or whether you want to do hands-on with me, because my approach will be different. If there is, you are also doing with me, then my approach will be different. And if you are not doing with me, then my approach will be different. So those who have given answers, I know they are ready to do hands-on. Others, please unmute and talk with me. Yes, no need to raise hand. You can unmute and talk with me. I have got 9 answers. So I need 10 to start. So those who are not giving answers, if you are here, please unmute and talk. That you are not in a position to do hands-on, then you just listen. But need to interact. What about Shushanto Mondol? Are you here, Shushanto? So, okay, we have got 10 answers. So, let us proceed now. Can you see my screen?
Yes, sir.
Yes, sir.
Yes,
See,
sir.
Yes, sir.
so we have discussed that there are 4 variables. One is pre-approved loan. One is whether they have put questions, whether they are interested in buying, whether they actually bought it or not, and what amount of down payment they can make. So from here, you can see that there are 4 variables. So these are the 4 variables. If you check the values, then for pre-approved loan, 0 is coded as no and 1 is coded as yes. Similarly, for interested in buying or questions rather, similarly 0 is coded as no, 1 is coded as yes. And for purchase, similarly again, if they have purchased, then it is coded as 1. If they have not purchased, then it is coded as 0. And down payment is a scale variable. It is not a categorical variable, so it is measured in scale. All others are nominal scale variables. So this is clear to you, the data set.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
So this is our data set now, and we know that we want to predict that how many of them have bought it and how many of them have not bought, depending on the variables: down payment, interest in buying, and pre-approved loan. So which variables have actually influenced them to buy or not to buy, we need to understand. And since our dependent variable, purchase or sale for that matter, is a binary variable coded as 0 or 1, so you know that we cannot apply multiple linear regression here. Here the independent variables are more than 1, it is 3 here, so we need to apply multiple linear regression. But since our dependent variable is categorical in nature, it is binary, so we need to apply logistic regression, and for that matter it is a binary logistic regression case. So this is clear to you when to
Yes.
apply
Yes,
binary
sir.
regression.
Yes, sir.
Now go to analyze, go to regression. Under regression, you can find this binary logistic regression. Have you got it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now click. Have you got this dialog box?
Yes, sir.
Yes, sir.
Yes, sir.
Now, which is our dependent variable? Purchase. Clear or not?
Yes, sir.
Yes, sir.
And bring all the independent variables under covariate box. Have you brought it?
Yes, sir.
My speed is okay. Can you follow me?
Yes, sir.
Yes, sir.
Now, I will, before going to this logistic regression, I will share with you a trick that in order to understand that which variables, independent variables are important, which is actually influencing the dependent variable, you may run a correlation just to make you understand before running logistic regression. Because you know that in case of correlation, correlation means whether the variables are related with each other or not. the assumption should be that the independent variables should be highly correlated with the dependent variables, and among the independent variables, the correlation should be as less as possible. Otherwise, there will be a problem of multicollinearity. So in order to avoid multicollinearity between the independent variables, the correlation should be less, and among dependent variable and independent variables, the correlation should be high or strong. So in order to check that assumption, we may go to analyze first before doing the logistic regression. If you come to analyze, if you come to correlate, you click bivariate, this dialog box will appear. So are you following me?
Yes, sir.
Yes, sir.
So now, can you tell me that which correlation we should use here? Pearson or Spearman? These are two popular correlation measures. Which one we should use?
Pearson.
If you
Pearson, sir.
please mute yourself. Only when you talk with me, unmute. Otherwise, surrounding sound is coming. I will not be able to hear, and you will also not be able to hear me. Now, the fact is that when our variables are continuous in nature, and if we want to find the relationship between the continuous variables, then we use Pearson. But if our variable is categorical in nature, here in this case, you know that we have a dependent variable which is categorical in nature, and we have independent variable. Out of independent variable, some are categorical, some are continuous. So you cannot use Spearman, then you cannot use Pearson, then you have to use Spearman. Clear? This is clear to you?
Yes, sir.
Yes,
Yes, sir.
sir.
Now I have to bring all the variables under variable box. Are you following me?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
now just click OK. You will get the result. Have you got the output?
Yes, sir.
Now,
Yes, sir.
now how to interpret? Just check. Purchase is the dependent variable. All other variables are independent. If you see pre-approved loan, the correlation coefficient is 0.472. It is moderate. Interested in buying, 0.515. Again, it is a moderate to strong. Purchase, between purchase and purchase, automatically it should be 1, because there should be no relationship between purchase to purchase. And for purchase to how much down payment is it is 0.325. Now, if you check uh, between independent variables, then you see between independent variables, between pre-approved loan and how much down payment, it is 0.087. So it is very small. Good. If you check between how much down payment and interested in buying, it is 0.373. Means somewhat correlated with each other. Moderate relationship. So this gives a signal that how much down payment and interested in buying, maybe two variables are not, any one of them should be important. Otherwise, they should not have a moderate relationship. Between how much down payment and purchase, between dependent and independent variable, moderate, it's okay. And automatically between self, it will be 1. So from the correlation matrix, you will get a signal that which independent variables are important and maybe which one is highly correlated with each other. So you can get an idea. Let's see, when we run logistic regression, then we can prove it that whether interested in buying and how much down payment, both are useful or not. That we will check. So this is clear to you, how to check the correlationship between the variables?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now, just make it a point that this is a question mark here. That interested in buying and how much down payment is moderately related. Both are independent variables. So both may not be equally useful. This is the question mark here. Now, let us go to the data set and start our logistic regression. So binary logistic, dependent variable is purchase. We are bringing it here. We are bringing all the independent variables under covariate box. So I think till now you can follow me.
Yes, sir.
Yes, sir.
Now you can understand that from the covariates means the independent variables, all are not continuous. Pre-approved and questions, these two are categorical, down payment is continuous. So we need to click the categorical part. Under categorical covariates, we need to bring the categorical variables. Which are the categorical variables here? Can you tell me which are the categorical independent variable here?
Pre-approved for loan and interested in buying.
Yes. So we are bringing it under categorical covariates. You can see here within bracket it is written indicator. So we have to change it. So put the reference category as first. When you have put the reference category as first and you click change, automatically see it will be changed to first. So we need to change it either last or first. Generally we change it to first. Click continue. This you can follow. You have followed this one.
Yes, sir,
Ye-
click.
You need to click first and you click change, automatically within bracket the categorical variables first will show, because you have a predictor category or the target category and that is
Sir, the first is showing in my the questions, not in the pre-approve. Pre-approve within bracket just it is written as indicator, and the questions within bracket it is written as indicator and the first.
so you have to
The
change.
same here, sir.
You have to change it. You have to go to the contrast and you have to change.
So, sir, after changing, it comes like questions as indicators and pre-approved as
Sir,
indi-
No,
it is
indicators
coming. It
first.
is coming.
no. You have to click the independent variable first. Then you apply
Yes,
this.
sir.
Okay.
Yes,
Otherwise,
sir. Yes, sir.
you have to choose it first. Then you apply.
Now
Only
it's showing, sir.
then it will show. Otherwise, it will not. So click continue.
Sir, sir, please repeat.
Yes. Tell me.
Uh, Actually, sir, it comes as questions as indicator and pre-approved as indicator first. Then what to do?
No, the questions you need to, again, you click questions here, you click it, you highlight it, then you make the necessary change. Only then it will be applied, otherwise not. Okay.
Uh,
Yes, sir.
okay, sir.
Clear?
Yes, sir.
Yes, sir.
So we can proceed.
Yes, sir.
Yes, sir.
So now you come to the options. Okay. Click options. Have you clicked options?
Yes, sir.
Click this classification plots and Hosmer-Lemshow goodness of fit test. Classification plots, you may choose, you may not choose. Let us choose Hosmer and Lemshow goodness of fit only. Okay, that will do. Hosmer-Lemshow goodness of fit test. Continue. Click OK. Now, see, all the outputs have been given. Have you got this output?
Yes, sir.
So now we will be interpreting one by one. So all of you have got the output?
Yes, sir.
Yes,
Yes,
sir.
sir.
So we will start interpreting.
Yes,
Yes,
sir.
sir.
So first table, if you come here, it is the case processing summary. We have got 30 data sets, no missing values are there. So it is showing that we have used the entire 30 data set. And in the dependent variable, we have coded as yes, those who are purchasing 1, those who have not purchased as 0. All these tables need to be interpreted in the fashion that I am interpreting now. Okay. And all the tables are not important, but I will only interpret those tables which are important, which you need to bring in your analysis. Means you have to, how you do it. Suppose this one you want to bring, you just double click and you click right, you copy and put it in your Word file. This is how we do it. Okay.
Yes, sir.
Now, if you check the beginning block classification table, this is the confusion matrix. I will come later. I have shown you in the PPT that what is confusion matrix. This is actually a confusion matrix. Here, if you just check what is the overall percentage of classification,
76.7.
so means that 23.3 is misclassified or wrongly classified.
Yes.
Now this is beginning block 0, means when you have not taken independent variables into your model. Before taking the independent variables into your model, this is the classification table or the accuracy rate. Now, if you have taken important independent variables later, automatically your classification accuracy should increase because you have taken rightly the independent variables which are influencing your dependent variable. So that's why it shows the beginning block as 0, and without taking independent variables, it shows a classification. And for this table, if we compare with the last one, this is also a classification table, but it is, you can check here, block 1 means here you have already incorporated all your independent variables. When you have incorporated all your independent variables, check here what is the accuracy rate. What is the accuracy rate?
90%.
90%. So initially when you have not taken independent variables into your equation, the accuracy rate was 76.7%. Now after taking the independent variables into your equation, the accuracy rate has increased to 90%. It shows that your model is a good model. Why? Because it has improved a lot when you have taken the independent variables, and your independent variables are correctly taken. They are meaningful, they are important. This is the conclusion. Clear?
Okay, sir.
Now, if you, all these no need to interpret. Now come to the omnibus test of model coefficients. If you see the chi-square value 16.843 and it is significant, it is less than 0.05. So what does this mean? what does this omnibus model mean? Actually, this omnibus test of model coefficients actually tell us about the overall fit of the model, whether it is good or not. So if it is significant, since here it is significant, less than 0.05, also less than 0.01, so at 5% level of significance, also at 1% level of significance, it is a good fit. So we can say that the table, omnibus test of model coefficient table, reports that it is a goodness of fit test. The chi-square is showing 16.843 with 3 degrees of freedom, and our sample size is 30. So capital N is 30 with a significance level of 0.001, which is less than 0.05. So it is significant. So we may say that our model is a good model, and the omnibus test of model coefficients table or result shows the goodness of fitness test of our model. It is a good model. Clear?
Yes, sir.
Now come to model summary. Here the model summary table actually gives us the additional information about our model after inserting the independent variables. If you check the -2 log likelihood, why? Because I was telling that logistic regression actually follows likelihood estimation, maximum likelihood estimation, MLE, not OLS. So from here you can understand it is following maximum likelihood estimation, and the column titled -2 log likelihood value shows 15.754, which is good, and the smaller the value it is best, the higher the value it is worst. So since it is small, the value is small, it gives credence to our model. And there is some controversy regarding this pseudo R square, because in multiple linear regression you need to interpret R square and adjusted R square, but here this is pseudo R square. What is the logic behind this? Actually, Cox and Snell R square and Nagalkar's R square, it tests actually some analysts say that it is not true, but R square in multiple regression gives a true value, but here this SPSS gives you a pseudo R square value. We may report them, uh, we may not report them, some may not report, some may report, but I feel that we should report it because it gives us additional information about the credence of our model. And if you check the value here, Cox and Snell R square is 0.430 and Nagalkar R square is 0.648. So we may say that the test values of 0.430 and 0.648, it suggests that between 43% and 64.8% of the variability in the dependent variable is explained by our independent variables. So again, I am repeating, we may say that between 0.430 means 43% and 0.648 means 64 and 4.8%. So we may say that between the test values of 0.430 and 0.648 suggests that between 43% and 64.8% of the variability in the dependent variable is explained by the independent variable. So it is good. It is explaining to the extent of 43 to 64.8%. Clear?
Yeah.
Yes, sir.
So if you have doubt regarding the interpretation till now, what I have discussed, you may ask me, or otherwise I will proceed.
Proceed, sir.
Okay. So now, if you check the Hosmer and Lemshow test, see, this is additional test which is applied in order to understand the goodness of fit test, whether we are able to evaluate our logistic regression model or not, whether it is a good fit or not. For that, to provide additional evidence of our goodness of fit, we run this Hosmer and Lemshow test. And therefore, you may see that the logic should be that it should be greater than 0.05. If the chi-square value and the degrees of freedom shows non-significant or insignificant result, it means that it is an additional evidence that our model is reliable. Here it is greater than 0.05. So if it is greater than 0.05, we may say that Hosmer and Lemshow test gives additional credence to our model, that our model is a good and robust model. And if it would have been less than 0.05, then it is very difficult to prove that our logistic regression model is good and robust. We have to actually stop running this logistic regression model if our Hosmer and Lemshow test fails. If it is good, if it is greater than 0.05, then we are assured enough that our model is a good and robust model. Clear?
Yes, sir.
Now, if you come to this classification, no need to interpret this. If you come to the classification table, I was mentioning that initially, before introducing the independent variables, our classification accuracy was 76.7%. Now, after incorporating the independent variables, our classification accuracy has increased to 90%. It shows that our model is a robust model and it is a good model. 90% is a very good model. If it is more than 80, you can say that it is a very good model. And since it has increased a lot from 76.7 to 90, means 13.3% it has grown. So it is good. Now, about this is the confusion matrix actually. This final classification table incorporating the independent variable is the confusion matrix. I will go on to discuss the confusion matrix with the help of PPT I have shown you. I will just now calculate it before finishing it off. So this is a little bit advanced analysis. I will come to it. But before that, just check the variables in the equation. Which variables are important and which are not. So if you check the significance value here, see pre-approved loan less than 0.05, it is significant. Questions are showing interest in buying 0.036, less than 0.05, it is again significant. But see, down payment is greater than 0.05, so it is insignificant. So it proves that when we have actually run our correlations, Spearman correlations, it has given us an indication that questions and down payment both will not be important because they are highly correlated with each other. And here at the end of our logistic regression, it proves that see, one is important, the other is not important, means other is not significant. So when we are writing the equation, the final equation, we will drop this equation. We will drop this variable from the equation because it is an insignificant variable. It is not helping to explain the variation in the dependent variable. So ultimately, out of 3 independent variables, 2 are significant and 1 is not. This is how we interpret. This is clear to you?
Yes, sir.
Yes, sir. Please, the last one, variables in the equation, please, sir.
Yes. Tell me.
How can I explain the variables in the equation?
You need to check the significance column, okay? If it is less than 0.05, means it is significant. If it is greater than 0.05, it means it is not significant. So what we are trying to do with the help of logistic regression, we are trying to explain the variation in the dependent variable. If our independent variables are significant, important, then it will help us to explain the variation in the dependent variable. So here it is significant. Again, this one is also significant, but this one is not significant. So we will drop down payment variable, independent variable from our equation because it is not significant. So actually these pre-approved loan and interest in buying, these are the two significant variables which are helping to predict the outcome variable, that is whether they will buy or not. Is clear?
Yes, sir. Got it.
Now let us copy this one. This will be vital because it will help us to do the confusion matrix. This is the one. So let us, I think you can see my screen.
Yes, sir.
Yeah.
So this is visible.
Yes, sir.
Yes, sir.
Now, if you check here, this is predicted outcome and this is the observed value. This is the actual, this is the prediction. So if you check, observed no, predicted no. This is rightly classified, 22. Out of 30, 22 rightly classified. Again, predicted yes, observed yes, 5 rightly classified. So the diagonal one, 22 plus 5, 27 are rightly classified, and the off diagonal one, 3, is misclassified. Why? Because if you check, the observed is no, but predicted is yes, 1. And again, observed yes, but predicted no, 2. So this is misclassified. So the off diagonal 2 and 1, 3 is misclassified, 22 plus 5, 27 are rightly classified. This is clear to you?
Yes, sir. Sir, is this the sensitivity and specificity?
Yes, that I'm coming here, actually.
Okay, okay, okay.
I'm coming. Can you check this? This is the classification table or the confusion matrix, we may say. When predicted is 0 and actual is 0, we call it as a true negative. So here we can write like this. You can see here, predicted is 0, no, and actual is 0. So we may call it as true negative. 22 is true negative. This is clear?
Yes, sir.
Yes, sir.
Now see, when predicted is 1 and actual is 1, we call it as true positive. So here, this one is true positive, 5. Can you follow me?
Yes, sir.
Again, see, when predicted is 1 and actual is 0, we call it as false positive. So predicted 1, observed 0, we call it as false positive. Again, come here. When predicted is 0 and actual is 1, we call false negative. Predicted 0, actual it is 1. We call it as false negative. So if you check this column, true negative and false negative, if you check this column, it is false positive and true positive. So the diagonal one is true negative and true positive, that is rightly classified, and false negative and false positive is misclassified. So this is the error. This is clear to you?
Yeah.
Sir.
Now, if you check here, I have given you the PPT. You can see the formula here. N is the number of observations. Overall accuracy is Tn plus Tp by N. So we may write overall accuracy is equal to Tn plus Tp by N. So what is Tn? 22. What is Tp? 5. What is N? 30. So 27 by 30. What is the value? 90%. Got it?
Yes, sir.
Now, what is the overall error rate? Fp plus Fn by N. So this is overall accuracy rate, which is this one. What is the overall error rate? What is the formula? Again check. Overall error rate Fp plus Fn by N. Fp plus Fn by N is equal to 1 plus 2 by 30. It comes to 3 by 30, that is 10%. Clear?
Yes, sir.
Are you able to follow me?
Yes, sir.
Yes.
Achha. What is sensitivity and what is specificity? I will come now. What is sensitivity? Tp by Tp plus Fn. Sensitivity is Tp by Tp plus Fn. So we may write Tp by Tp plus Fn. So what is Tp? 5. What is Tp? 5 plus what is Fn? 2. So it is 5 by 7. So can you tell me what is the value? Can anybody?
0.71. 0.71.
0.71 means 71.4%. So
70.
actually, this is the sensitivity. Clear?
Yes, sir.
And what is specificity? Check the formula. Tn by Tn plus Fp. Tn by Tn plus Fp is equal to what is Tn? 22. What is Fp? 1. So it is 22 by 23. How much it is coming? Can anybody tell?
95.65.
This means this one. So this we call specificity. This we call sensitivity. Clear? So overall accuracy of our model is 90% and overall error rate is 10%, which is very good. Generally, this if you want to reduce this overall error rate, because logistic regression has certain limitations, because you are actually trying to find out again a linear relationship between the logic transformation and the independent variable. That's why this misclassification comes, this error comes. So if we can use a non-linear regression, that is called support vector machine, which is called SVM. SVM is a machine learning concept. Actually, it helps us to reduce the overall error rate. It will come to 2 to 3% if we use these support vector machines. So I think I made it clear.
Sir, one question, sir, is there?
Yes.
Actually, sir, variables in equation, there is a relationship between down payment and the purchase. That and the significance level was 0.351. So should I leave this one, and after that we should go for logistic regression? Then the result will be better.
Generally, what will happen is, now if you after seeing this, if you reduce the down payment, if you omit the down payment, if you run, then a little bit improvement may take place. Okay, but when
Okay.
you are doing research, when you are showing it in your result, if you only show only the significant variables, then the reviewer may think that you have manipulated. Okay, so
Okay, 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 sir.
it is better to keep some insignificant and to interpret in that fashion.
Okay, okay, sir. Thank you.
Okay. So I am just now stopping my sharing. If you have any doubt regarding the demonstration that I have made today, you may ask me. And I have supplied you the entire data sets. So at your convenient, you may practice the terminate data set that I was talking about. And real estate data set, I have already used it for discussion today. So if you have any doubt regarding today's demonstration, you may ask me, or otherwise I will finish it off by discussing the practice data set so that you may able to practice it. So if you have any questions to ask, you may ask me. Otherwise, I will finish off with discussing with you the practice data set.